Yes, I got this. Thank you very much. Thank you, Shri. Okay, so in this session, this is the lecture 16, session 2, final session of this course, and we are going to see the K-means algorithm right now. And however, I hope that this algorithm should be clear in your mind because we have spent a lot of time for that. So, may I ask one question only, that is whether the algorithm is clear pictorially in your mind? Is it clear in your mind? No? Is it clear? Yes? Okay. So then let's verify that whatever we have in my mind, our mind is correct. So what was the first step? That we created the centroid or the representatives. So randomly select the k points, means randomly as a centroid. So initially this is then the first step where we have placed the centroids at the k places. Okay, clear. Next is the datum point. For every datum point, every data point that we had, we try to find out that which particular centroid this particular item it is, based on the some closest. We wanted to use the closest property, and therefore every data item was actually assigned to one other centroid. So this we have done for each data points di. What we have done, we have assigned this to the one other centroids. Is it clear? Is it clear? No. Today you are not excited. Everybody is making delay. All right, ठीक है ना? It's very clear that when we have a centroid, we have assigned all the points to the centroid. Then the next step was very simple step: recompute the centroid, because we know that if it is a centroid or representative, it should be near. So we have recomputed the centroid. That is just taking the mean of each clusters. So we have find out the mean of each clusters, and by this we have find out the new centroid. And we are going to do this multiple number of time until the centroid converges, means when there is no change into the centroid. So this is what the algorithm is, and that is very straightforward and simple. Now the point remains that how to find out that what is the meaning of this closest centroid. So we have seen that one method is the Euclidean distance, that just seeing that what is the distance. Second could be the cosine similarity. That may be useful when the data is multidimensional. So you see that what is the angle. So items which have the lesser angle would have the higher similarity. You want to find out, sometime you may use a correlation and or some other divergence features such as Bregenman the divergence. Also other means multiple things are possible. That depends upon your requirement. You can use any closeness measure. Okay, so that's all. This is the k-means algorithm. Okay. So this is nothing more than that that our previous whatever execution we have done. So here also there are, you see that these are the data points and they have a color, and their color is only because of these centroids. So there, let's assume that one centroid is here, one is here, one is here. So you can see that the data point would be assigned to this particular centroid, these are assigned to this, and these are assigned to this. So in the first iteration, what would happen? You initially put these centroids and assign them, and then you recompute. When you recompute, you see that they are going to change, and therefore you see that then you see that these items are now assigned to this, and the assignment varies. So you go ahead from this to this, and you say that now different assignment, and you see that even different assignment, and at the end you see that after 6 iteration, nothing is going to change, and therefore you stop. So this thing we have discussed in detail. I think no need to explain much, but for the slides, it's important that you see that how we are going to do this. All right. So when we have come up to this particular thing, means k, when we have given k clusters, so how good we are, and so therefore there should be some evaluation. Means we want to find out that how good my k-means clusters are. So the goodness factor actually this is the formula that we can utilize. I am going to explain this to you. So let's assume that a data set is given to you that contains n data items, x1, x2, xn. Okay, is it clear that n data items are given to you, and let K means partitions it into S1, S2, Sk. Okay. So what does it mean actually? Hmm? So I want to say this particular point that so what I want to say, the x1, x2, xn means what? Let me just put this into perspective. Let's assume that x1 is a data item, x2 is a data item, x3, x4, x5, dot dot dot, xn, n data items are there. And sk means sets. So every set, let I say S1, say the red cluster. Okay. What is the S2? Say green cluster. Okay. What is S3? Then I call S3 third set. It is telling K cluster. Na? Here I am assuming the K is equal to 3. So S3 is equal to say blue cluster. Okay. So you would be at the end what you are going to find out, that this item is into this set, 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 this item is into this set. This thing you are going to find. Is it right? Okay, all right. Oh, there is a lot more things to understand. Okay, huh. So let us continue. So what I was telling that before this thing. So I was telling this thing that this set contains these items. Okay. Similarly, you can see the second set contains S2, and it has X, X1, X, X1, X5, and dot dot dot. Okay. You can say that S3 contains X4 and Xn and more items. Okay. So you know that every set that you have has some coordinate for the, what is the coordinate for this, what is coordinate for the representative, because there is a representative, and I say that this representative is mu as mu1. Representative is a mu1, and this representative I say mu2, and its representative is mu3. What I am telling? How come I bring the mu? Because there is a representative now. There is for every set there is a representative. Do you understand this? That if this is a set, if this is a set, then there is a representative. For every set there is a representative. There is a representative, and this representative is also a point. And at which location it is? We have. If I want to say that the location of this particular point, so let me say that this is the location of this item is mu1. Location of this item is mu2. Location of this item is mu3. Representative is the center of the set. And representative is the center of the set. You know that this representative was a centroid. It was a centroid. Every representative was a centroid, because we have only just find out the summation of x and the summation of y divided by number of items. This is the formula of centroid. So therefore we have put the mu for this, And then what should how should say that how good I am? Okay. If we want to find out that how good I am, how should let me just do one thing. So can I remove this? I think you understand this part. Everybody understand this part? So can I remove this part? Okay, can I remove this? Yes, sir. So that we have a space and we can write. Let me remove this part, okay, so that I can write more. So this is the formula that I want to tell you, that what this formula is. So where this particular line is important, where mu corresponds to the ith centroid, and you so say that this is not a different thing, and this, you see this formula, okay. All right, let me just put this. Don't see anything else. So I was telling that these things are centroids, and how to find out this centroid? To find out this centroid, you see that you find out the summation of, you find out the summation of all the x and divide by the number of items over there. So how many items are there into this set? If you want to find out mu I, sorry, if you want to find out the mu I, ith mu, so you should say ith set, na? How many items are there? Mod of Si. Ith set, how many items? This actually represents the cardinality in the mathematically. If I write two lines, it means that how many items are there. So for example, this every set is different, therefore number of items would be different. So 1 upon this, and then on the upper you find out the summation. For all the x which are there into Si, you want to find out the summation of x. Okay, and now it is a short form. Okay, this is a short form because if it looks like that the x is only single dimensional, but actually x would be multi-dimensional thing. So you can find out. If you have any confusion, I can go in detail, and hope it is not required. Is this like taking average? Yes, it is averaging only. I told you na, the averaging formula. So if you want me to go into the detail, I can go, but I think it is not required. So it is fine, na? Is it fine? No? Somebody is telling no. A little more explanation. All right. So let me give you a little more explanation, and that explanation, I think, please ask you, because anybody who asks the explanation who helps complete class, okay, please ask the explanation whenever it is needed. So I want to tell you this one thing that is actually hidden over here, is not being placed just for the sake of brevity, so that everything looks nice. So you see that this xi is actually not a single item, because xi contains, because if it's a two-dimensional thing, so for every xi would have the x component and xi would contain y component. So do you understand this part? Because we have, whatever example we have seen into the two-dimensional thing. So this xi is actually not xi, it is actually xi x and y, two coordinates are there. So therefore, this yi would also be not this mu I would not be only the mu I. It would be the mu I x, and you have to specify two values, mu I of y. These two values you need to specify. Okay, for every I you have to specify these two things. Then only the mu would be specified. To find out the first one, that is, and I think later other things you would pick up with me. If I want to find out this thing, so how to find out this mu I x coordinate, you find out the summation of all the x coordinate, whatever x you have into your set, ith set, for them you find out the summation of x. Okay, and you divide by the number of items which are there into the ith set. So is this formula clear? Similarly, if you, because two values you need to specify, the second item, that is mu I y, if you want to find out, this is the summation of, you say for all the items which are there into ith set, you find out the summation of their y values and divide by the number of items into Si. So hope this formula is clear. So can anybody say yes? Got it? So this is what was the hidden that I wanted to tell you, that however we have just written this formula, and this formula actually is looks like a single dimensional, but you can extend it in this way. So if you are okay, then why two summation in the formula? There is no two summation, single summation. Where is the two summation? This, look, to represent this particular value yi. If you want to represent yi, you have to tell what is the x coordinate and y coordinate. For the x coordinate, you are finding out the summation on the x. For the y, it is this. Okay. Somebody is telling first line. Where is the first line? Meera, where is the first line? Meera, please tell me. I want to explain you. Where is the this thing? You want to find out what is this? I is equal to 1 to k. Acha, acha, okay, I understood. You are asking about this thing, Meera? Are you asking about this thing? Yes? So hold on. We are not there. Okay, we are not there. We are still not there. We are at this. We are not gone to this formula. All right, it would be clear. Hold on. So I just want to remove these things, and I want to. I assume that you know that what is the value of mu. Okay, so now you understand this, that what I mean by mu I. When I say mu I, then you understand that what I mean by this. So let me just remove these things. All right, let me just remove these things. So now you understand that there is some x, there is some y, and that we have not discussing, but you can find out just what is the, for every mu you can find out what is the value of x and y. Similarly, x is a data item, but you can find out what is the x coordinate and y coordinate. That is straightforward. Okay, then my task is I wanted to find out how good this particular assignment is. Okay, so if you want to find out how good this assignment is, you see that what is the difference of this item with the mu1, because this item representative of this item is mu1, so there would be some distance. Okay, what is the distance of this item? Which is this item? x2 with respect to the mu1. Okay, what is distance of this item? That is distance of x3 with respect to the mu1. And similarly, you find out distance of all other items. See, can you see this? Because this mu1 was a representative, and therefore the distance between these items should be small. Okay. Similarly, here I write the distance of the x1 with respect to the mu2. Okay. Distance of the x5 with respect to the mu2, and dot dot dot. All right. Similarly, to the third example, I would say that distance of x4 and mu3, distance of xn and mu3, and dot dot dot. What is the distance? Because they are nearer. And if it is a right kind of assignment, means this is the right way to find out this thing, then these distances should be smaller. So what I need to find out that how good I am. So I would say that I would find out the summation of okay. All right. So what I say that this is the summation. Similarly here, This is the second line. So if I add all these things, it comes out with the summation of x belonging to S2, and it is the distance of x with respect to the mu2. Alright, similarly here it is summation of all the x which are inside S3. I want to find out the distance of x, whatever x there, with the mu3. Okay, you see that this is the distance for with respect to the every set that we have created. Can you see this, Meera? Hello, am I audible, Meera? All right. So I was telling to, can you see this, that for this set this was the distance, for this set this was the distance. So overall, if I want to find out if overall the goodness, if I want to find out for this algorithm, I have to find out the summation for this thing, because S1, S2, S3 is changing. I say I is equal to 1 to K if I want to just this thing. Okay, so this thing can be written as a summation of x belonging to Si, and I want to find out the distance of x with respect to mu I. Can you see this formula, Meera? Can you see this formula? Do you understand this? Fully understand this formula? Do you fully understand this formula? Yes? Okay, alright. So let me copy it, Control C, and let me go upside, and let me print it here. So this was the formula I'm talking about. Okay. So for I is equal to 1 to K, you see that here here this is the formula. For I is equal to 1 to K, the same thing, I is equal to 1 to K. X belonging to Si, distance of this is the distance. And putting distance square is also not a different thing. If it is Euclidean distance, then you can square or whatever you can put, that is not a different thing. So that is not a big issue. So you just see the same formula over here. But one more point is there. What is argmin? Argmin means you want to minimize this value, whatever, because this is what the distance is. Your objective is to minimize this distance, because if this distance is minimum, then your things are better. So therefore, you want to find out such S. What is S? S contains S1, S2, S3. S is a set that contains what are the S1, S2, S3. So you want to find out such S which minimizes this value. Okay. So that is a very important line that we have come up. So we have come up to this, that where mu I correspond to the ith centroid, and we have seen that for given data set our task is this. So if our task is this, we are done. Okay. So our task is into the K-means algorithm. In the K-means algorithm, our task is to find out the value of K, to find out the our task is to find out such sets. Yes, that is a partition. Such partition which minimizes this value. Okay, you understand this thing? I think it should be clear now. And people are asking what is the value of K. So as I told you, that K is provided by the user. He specifies from the first point. I am telling this, that user specifies that how many different clusters I want. All right. So now I think and I told you that the value of K comes from the understanding of the data. So it is a kind of knowledge that the system designer provides into the system, but sometimes there are some ways to find out this. So we would be discussing that. Oh, Meera is asking. Great, Meera. Thank you, Meera, for your comments. She is writing. Great explanation, sir. In the last semester in the machine learning, it was there, and since then it was my query, which was not answered. Okay, all right. Thank you. So you please ask the question. If you are writing right questions, I would try to give my explanations. All right. So, so now we understand that what this formula is and what we want to do, but how to find out the value of k remains a question. So how to proceed means how to choose the value of k. So there are some guidelines that I want to put into your table. That run the k means algorithm multiple number of time with a different k values and try to see which one is the better. Okay, multiple number of time you run this k means algorithm. Suppose initially you run with the k, say with the value 1, then you run with the k 2, 3, 4, and see that which is the better one, which better suits you. Choose the cluster corresponding to the one that minimize the sum of square error, and that is a strategy that you want to minimize this thing. So you are choosing one which minimizes this particular thing. But the point is that the k is equal to if k is equal to n, then there is no error. So good algorithms has a smaller k. So actually, let me just take this thing and explain you to there. All right. So let me put it here. So I want to tell this thing to you that what I want to tell you. Okay. This is an important point. That all right. So okay. So the point is that number one that I want to bring in your table, that if say k is equal to 3 and you execute the algorithm and try to see what is sum of square distance. You know the sum of square distances? The same formula, same thing, that what is inside. If this is the sum of square distances, you find out that what is the sum of square distances, and you found out what is the sum of square distances. Let's assume that it comes, I'm just writing a weird value, 2.93. Okay. Then what you do, if you again run the algorithm with the k is equal to 3, what would the value? Would it be 2.93? Would it be 2.93? Is it fine? Is it fine? Okay, all right. Okay, so I was telling this thing that if you execute the algorithm once again, you may not be getting the same value, you may be getting a different value. Yeah, and differently, if you again go for the third iteration, k is equal to 3, and you again execute, you will be getting 2.88. So my point is that you run the algorithm multiple number of time, and this is the standard way to do this, multiple number of time, and you take the average. Whenever you want to repeat that, what is the provide that for k is equal to 3, what is the answer? You take the average or median, whatever you wish. You take this particular value. So that is the good representation. So for k is equal to 3, and this particular graph, I want to tell you this particular graph. Here I am increasing the value of k and want to find out what is the sum of square errors. So you see that that if here is the value of k, I take the k is equal to 3. Okay, I see sometimes this value, sometimes this value. Errors are actually different. Errors are different values you are getting. So that I'm telling that if you have a if you fix the value of k, then you will be getting a different values of k, and then you can take the any average or anything to tell that actually this is the value. Similarly, you can change the value of k, and again you find out different value, and you can draw a curve out of that, because you know that when the value of k increases, SSE is going to decrease. Why? If number of k is equal to n, means every item n means every number to the number of item, then there would be no error. So this is actually extreme. You don't want this. You want the smaller value of k that we have already talked about. So you see that one way to go ahead with the data. If you don't know anything, if you don't know anything, no audio, Mira, no audio came back. I don't know what is happening. So what I want to tell that that you execute the algorithm multiple number of time and try to see that what the curve is coming, and at some point you see that initially there is a very high decrease, and after some time you see that it is going to be flattened. So you just pick that particular, and you see that at some point it would cut this particular line, because at the end it should become 0. So you pick some point where there is no much gradient as a standard value of k. So this is how you can go ahead to find out the value of k. So alright, so this is how you can find out the value of k. Okay, so evaluation means if you want to find out how good it is, we have seen that. So you see that the choosing the value of k, how can you choose the value of k? One method we have just recently discussed. Another one method was, first method was the user can provide if you have the domain knowledge. Okay. Another thing could be iteration on the k. And one more method that I want to tell you, that you pre-process the data with another algorithm and try to see that what thing you get from there, and then you can apply. And one such method could be singular value decomposition, or you can see that the PCA you can apply and try to see that how many different components are there, and other methods you can apply and try to see, and then you can apply over there, because it gives you a center-based approach. So sometimes if you are applying another approach, then you can apply here center approach to find out how many different clusters are there, and you can solve it. Now the question remains that how to initialize the center. So we have talked about that. We have, in our example, we have randomly picked into the space, and there could be random data point. You don't put anywhere into the place, you put a data point and you move from one data point to another data point. That can also be possible. Look for the dense region. You just initially scan the area, try to see the places where there is a lot of data points are there. You put your representative there itself, and then you start. Another way that you find out, since a space is given to you, you find out that these are the points from where you can give the maximum coverage, and space them initially you space them into the uniformly into the feature space. All right. Sometimes you want to find out how good my cluster is. So one such method is the diameter of the cluster versus the inter-cluster distances. Means you see that what is the distance between the two clusters and what is the size of cluster. A good clustering algorithm would give you clusters so that distance would be higher and inside distances would be lower. Distance between the number of member of clusters and the cluster centers. So diameter of the smallest pairs, just see that which is the smallest pairs, ability to discover hidden pattern, etc. There could be some problems also. Sometimes if you are going with the k-means algorithm, so you can have some problems, such as this is the data. So can you tell me how many clusters are there? If this is the data, how many clusters are there? 3 clusters. All right, 3 clusters are there. But suppose that by chance we have initialized one of the centroid at this particular location, that is actually the center point of all these points, and you see all these things are actually away from these points, and you initialize 2 centers over here. Okay, you initialize two centers over here, and one center is just mid between of these things. So what would happen that if you assign all these points to some of the centroid, they would be assigned to this centroid, and therefore and its center is its location is not going to change. Only points which are assigned over here, means these centroid and this centroid, they are going to change, and therefore you see that this is a bad clustering. Is it a right clustering? What should be the cluster? This should be the one cluster, second cluster, and the third cluster. But actually, your algorithm is going to give you the cluster of this kind. So, do you see that there is an error? Do you see that there is an error? Yes or no? Do you see that there is an error? All right, there is a problem. You can see that there is a problem. So, how to come up with the problem? This. So you know that this problem happened, and because of the wrong kind of initialization, and since we are randomly putting the items over there, so it is very less likely that the second time it would also happen the same thing. So you run the algorithm multiple number of times, 3-4 times, and definitely once you got the sum of square errors here, the sum of square would be very high. But when the classification clustering would be right, then at that time your sum of square error would be small. So out of those three things, you can find out if you take the median, you can say that this is the better one, or the smaller one, minimum one. Then you can say that this is the better one. You can neglect these three things. So one way to do this. And another problem could be that this particular algorithm faces problem when the data have a different size cluster. Here you see that the size is different. Then you see that there could be a problem. Different densities. Then also this algorithm faces problem. No globular shape, means you see that if here all these places you see that there is a global shape. You can say that there is a circular thing, circular thing, circular thing. So if there is no global shape, then also this algorithm has a problem. Handling empty cluster is not possible because and how can you say that what is empty cluster? Means there is a cluster which is not assigned any point. So this you cannot do over here. And why it is needed? Because it is not the case that only you are adding the thing. Sometime into the dynamic environment you have some clusters, and some points are get added and some points are get deleted. And when the points are get deleted, it may be possible that at some later point of time, all the points of this particular cluster has been removed. But in between, when you have when you are doing the processing, you have discovered that there is a process, there is a thing that is available there. But now, since there is no evidence, you are telling that concept is not there. Sometimes it is not a good idea because you have seen the data, you have explored some pattern, and now there is no data there for that thing you need to kill, and that is not a good idea. So therefore, it is a problem. It cannot handle the empty clusters. Also, there is a big issue that when there are outliers, for example, if I put a point very distance, then since this algorithm classifies every point, clusters every point, then that point would also be included, and therefore the things become skewed. So this is again a big problem. Also, updating centroid incrementally is not possible because what do I mean by this is that let's assume that you have some data points, okay, and you have applied a k-means algorithm to find out the clusters, and you know that this is a difficult task because with every data points you have to find out the centroid and all other things. Lot of computation you have done, and most of the time we assume that the data points are very large. So if those large number of data points, you have spent some time to find out the solution. Now, if somebody gives you one more point and asks you that can you give me where should be the centroids? So it becomes impossible for you to process because incrementally you cannot go ahead. Again, you have to execute complete algorithm. Can you see this? Can you see this? You have to execute the complete algorithm once again. And that is not a good idea. So you understand this, what I'm telling? Do you understand this, what I'm telling? No? Yes, no? I am telling that if you have a data and you have applied k-means algorithm to find out the clusters, now you have the clusters. I am telling that let's assume 10 hours you have spent to find out that these are the clusters. Now I am going to give you one more point. I am going to ask you that can you give me the what are the clusters? It becomes very difficult for you to give the clusters because however, the incremental way you can say that I would find out that this particular point lies to this particular cluster and therefore I am assigning this clustering. But this clustering would not be same if you have done from this processing from the scratch. All right. So therefore, this is only an ad hoc method. The actual method you would be that what is the answer coming from the scratch and coming from this way should be same. It's not going to same. So incrementally, you cannot apply this thing for a new item. Finding out again the new updated k-means clustering would again need you to spend 10 hours. Now that is a big problem. All right. Once again, this particular slide is very specific, and just to give you a reiteration of the fact that k-means and knn are the different algorithm. And we have, however, we have discussed, and the distance is that knn is a supervised approach for the classification. We have seen that nearby items, what is their classification, and then we want to find out what are the k items which are near to you, and then we have done a voting to find out the classification. But here it's not the classification, it is k-means is a clustering approach. K-means is a clustering approach. All right. So we have discussed this thing. I think Manish, your question was this, and we have addressed this. Is it fine, or you want to ask anything? All right. Okay. So let me talk about some other clustering approaches, because we have seen one approach, that is k-means, and another approach could be k-medioids, and that is not difficult to understand. Choose the data point as a centroid. Okay. Now here I am telling that instead of the data point, instead of the any place that you can put, because you find out the summation and you see that this is the place centroid is, so you put the centroid over there. But there is no data point. How can you say that he is representative of the data? That is a big problem. Look, for example, if you want to find out that who is my representative, and you want to find and you take the centroid, at that location there may not be any data point. So what is better approach, that if you find out the centroid comes here, so you find out the nearest point over there, you go to that particular point, because this is the actual data point that can be represent something. This is the data point. So every time you go to the particular data point, and you only, whenever centroid is computed, you just shift to reach the nearest data point, and then you do the computation. And if you modify the algorithm in this way, then it becomes k-medioid. Another approach is agglomerative or hierarchical clustering approach, and one such approach is a single link approach, and that is also a very simple algorithm. Sir, one bad question. What is the difference between classification and clustering? No, this is a very good question. Classification actually means that if I give you, very good question Vijay had asked. I want to give you the answer for this. Please concentrate that what I am telling. Okay. One thing, the question is the difference between classification and clustering. Okay. Difference between classification and clustering. So there are two approaches. There are two problems that we want to address. First problem, given the data, you want to understand what is inside the data. Number one. Second thing, given the data, you want to learn from something, that whenever a new item comes, what is its classification? Can you find out what should I do with this? Okay. The first thing, given the data, I want to understand what is inside this. Number one thing. Given the data, you want to understand what is inside this. Number one. Second thing, given the data, you want to learn something, so that when the new data comes, you want to do something with that. Do you see that there is a difference? Okay. In one approach, you are confined into the data. You are not seeing that what is beyond the data. Okay. This is what the clustering is. Okay, given the data, you want to understand this data. How many different parts are there? It is the clustering. You are not concentrated that when the new things, what is beyond the data is. Clustering is just seeing that what is inside the data. Clustering means trying to see that what is inside the data, understanding what is there. Classification, given the data, you want to make some model so that when a new things comes, when what is beyond the data, is extending beyond the data, then I would do something with that. This is the main difference. Do you understand this, Vijay? Should I explain more? Clustering is understanding what is inside the data. Classification, understanding what is beyond the data. When a new data comes, what is there? Application is beyond the data, but clustering and application is inside the data. How many different things are there? We want to understand that. We want to, after doing the clustering, what you can do, you can do the summarization, because you know these things are similar. So you can take one representative, say that chalo ye kar liya. Okay, so you, after doing clustering, you can do the summarization. All right. So we are talking about the agglomerative hierarchical clustering. I want to tell you that there is an algorithm called single link algorithm, and that is very simple algorithm. It is hierarchical clustering. Acha, hierarchical and agglomerative is a single name, means they mean same. Agglomerative means hierarchical. So let me give you an example. That would be very good thing for you. So let me give you this algorithm. So I am going to talk about S-link algorithm. Okay, so let's assume that there are few data points I have, and I want to find out how many k is equal to 3. Please help me. Okay, I cannot solve this thing. So let me say that these points, without your help, I cannot solve. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. These are the data points. So can you tell me? So initially, what I say that there are 11 clusters. How many clusters we have? 11 clusters. Say 11 clusters. How many clusters we have? 11. All right. I want to make them 10. So can you tell me two items which are very near? Can you help me? I don't know, but let's assume that these 3 and 4 are very near. Okay. If 3 and 4 are very near, so I would say that they are 1 point. I say now how many clusters? 10. Okay. So which 2 points are nearer? Next 2 points which are nearer. So looks like 8 and 9. So if 8 and 9 are nearer, I say that they are there. Then now I have 9 clusters. Which 2 points are nearer? Okay. Next 2 points are nearer. 2 and 3. Somebody is telling 2 and 3. Okay, 2 and 3 are nearer. So in one cluster there are 3 points. I just see that 2 and 3. Okay, now I have 8 clusters. Which 2 points are nearer? You just write anything. 5 and 3. All right. If 5 and 3 are nearer, so I say that 5 and 3 are nearer. This is one cluster. Now I have 7 clusters. Which 2 are nearer? 1 and 2. Okay. So ये तो गड़बड़ी चल रहा है. 1 and 2. Now I have 6 clusters. Which 2 are nearer? Which 2 are nearer? Just 3 and 6. Okay. 3 and 6. Let's say 6 and 7 also. It would be happy. I would be happy. Okay. So now I have 5 clusters. Which 2 are nearer? Say 10 and 11. So I am more happy. 4 clusters. Which 2 are nearer? Say you say that these things are there. Now I have 3 clusters. I have stopped. How many clusters was it required? 3 clusters. If I wanted 3 clusters, I find out 3 clusters. This is how I go ahead. If I go ahead in this way, this is called S-link algorithm, where all these things would be called on the cluster 1, cluster 2, and cluster 3, and the name is not important. All right. Okay. So we have seen this, and next algorithm is the DB scan algorithm. That is a density-based clustering algorithm that produces a partitional clustering in which the number of clusters is automatically determined by the algorithm. So DB scan is very interesting algorithm that here you need to specify the value k, and by itself it decides that what should be the appropriate value of the k. Okay, so can anybody tell me that he knows the TB scan? Have you heard, anybody heard about this, know about this algorithm? Hmm? Say yes. Yes. Okay. All right. I think if you know this, you can read this, and this is a very simple algorithm that uses two parameters. One is the radius, and another is the how many points should be there inside the radius. And the let me just give you the understanding that what is this? Okay. Oh, कुछ तो गड़बड़ हुआ. Okay, I got it. Okay. So what I was telling, the two parameters are there. What is the radius and what is the min pits min PTS? How many minimum points should be there? So let's assume that these are the points and these are the points. These are the points. These are the data points. These are the data points. So what it does, it initially find out for every point it draws this radius, and there should be, if min point is 3, so 3 points should be there. So this point is this particular point is not core point. By this is say that core point. Okay, this point is not core point, but see, okay. Hello, hello, hello. Am I audible? Huh. So what I'm telling that here's I was telling that there are few points which are core point and there are few other points which are the border points. So this algorithm says that every core point you take and say that this is the cluster 1, and if there is inside the nearby there is a core point, this is also into the cluster 1, this is also into cluster 1. So it applies a DFS on that to find out what are the points that are nearer, and when it stops, so this becomes a cluster, and the border point which are near to the core point, they are also given the same cluster in things, so therefore it becomes one cluster. Similarly, here you can see that there will be one more cluster, and the most important part is this, that these points are actually not given any cluster because they are neither core nor the border. Okay, so I told you that the core point is the point. Core point, a data point is core if in its R neighborhood that is being specified, there are min points number of points available. Okay, so you can see this algorithm, min point number of points are available, then it is core. And this point, which is not a core point, but if you draw a circle over here, you see that there is a core point there. So for that particular point is called the border point. All other is a noise point. Okay, so these are the noise points. So they are not classified. This is the best algorithm that tells that these are the errors, these are the outliers. So this is another approach that I want to mention to you. So I think that's all for this particular session, and thank you very much for being with me in this course. I enjoyed this a lot and hope you also got some understanding. Happy Diwali to all of you, and enjoy. And this was the final lecture for this artificial intelligence course, and I am very happy that to being an instructor for you. So that's all for today. Thank you very much. Best of luck for the exam.